morning everyone. My name is Saransh and I am a lecturer in Freshly and Nehari University. And today we will discuss about heat exchanger. Here we discuss about definitions of heat exchanger, example, purpose, and its types. First of all, we will discuss about heat exchanger. A heat exchanger is a system used to transfer heat between two or more fluids. Heat exchanger are used in both cooling and heating processes. The fluids may be separated by a solid wall to prevent mixing, or they may be in डायरेक्ट कॉन्टैक्ट तो फर्स्ट ऑफ ऑल अगर अपन हीट एक्सचेंजर के बारे में बात करें तो ये चीज़ तो ये वो जो पर्टिकुलर वर्ड जो है कि ये हमारे नाम से क्लियर है कि हीट एक्सचेंजर मीन्स हीट का मतलब कि हीट एक्सचेंज बिटवीन दो या दो से ज़्यादा फ्लूइड्स मतलब किसी भी जब सिस्टम के अंदर दो या दो से ज़्यादा फ्लूइड के बीच में जब भी कोई हीट एक्सचेंज होती है तो उसको तो उस डिवाइस को उस पूरे प्रोसेस को उस सिस्टम को जो है हम हीट एक्सचेंजर बोलते हैं लाइक अगर अपन बात करें कि कोई भी मतलब कि वो जो सिस्टम के अंदर मतलब कोई भी जो सिस्टम है उस सिस्टम के अंदर डिफरेंट डिफरेंट कॉलम्स मैंने बना दिए और उनके और हर एक कॉलम के अंदर डिफरेंट डिफरेंट टाइप्स ऑफ फ्लूइड्स लाइक वाटर ऑयल एक्सेट्रा ठीक है और जब उनको जब हीट दी जाती है तो वो जो फ्लूइड्स जो है तो वो चेंज हो जाता है ठीक है तो तो उनकी हीट जो है वो एक्सचेंज हो जाती है क्योंकि जब दोनों आपस में जब मिक्स होंगे तो उनकी अपनी डिफरेंट प्रॉपर्टीज़ होगी और वो प्रॉपर्टीज़ जब एक दूसरे के साथ मिक्स होंगी तो वो उनका जो टेम्परेचर जो है वो चेंज हो जाएगा दो या दो से ज़्यादा फ्लूइड्स का और ये जो है ये हमारे दोनों प्रोसेस के अंदर यूज़ में आती है लाइक कूलिंग प्रोसेस एंड हीटिंग प्रोसेस द फ्लूइड्स may be separated by a solid wall to prevent mixing or they may be in direct contact that is called heat exchanger. Now we will discuss about examples of heat exchangers like automobile radiator, condenser, evaporators, air preheaters and cooling tower. First of all अगर हम ऑटोमोबाइल रेडिएटर के बारे में बात करें तो ऑटोमोबाइल रेडिएटर के अंदर और तो किसी भी व्हीकल के अंदर जो है हमारा हीट एक्सचेंजर लगा होता है वो हमारा कूलिंग का काम करता है जब भी कोई हमारा जो व्हीकल को जो स्टार्ट करेंगे और व्हीकल को स्टार्ट करने से लेकर जब हम उसको बंद करेंगे तब तक हमारा जो इंजन जो है वो बंद हो चुका होता है तब उस कंडीशन के अंदर हम यहाँ पर कूलिंग प्रोसेस का तब हम यहाँ पर हीट एक्सचेंजर लगाते हैं हीट एक्सचेंजर हमारा कूलिंग का काम करेगा और अगर हम हीट एक्सचेंजर नहीं लगाते तो वो इंजन हमारा फट भी सकता है ठीक है तो उस चीज़ को ठंडा करने और उस चीज़ को कूलिंग प्रोसेस के लिए हम यहाँ पर हीट एक्सचेंजर यूज़ करते हैं लाइक इसी तरीके से कंडेंसर यूज़ करते हैं कंडेंसर इज अ प्रोसेस इन विच गैसेस आर कन्वर्टेड इनटू लिक्विड फेज मतलब कि ये भी ठंडा करने के काम में आता है तीसरा इवेपोरेटर्स मतलब कि वो जो वेपराइजेशंस जैसे कि अभी हमने बात करी कि जो हमारा हीट एक्सचेंजर जो हमारा होगा वो हमारा कूलिंग और हीटिंग दोनों प्रोसेस के अंदर काम करता है इसी तरीके से हमें यहाँ पर हमारा कंडेंसर के अंदर भी यूज़ आएगा और इवेपोरेटर के अंदर भी यूज़ आएगा लाइक इस तरीके से हम कूलिंग टावर के अंदर भी यूज़ में ले सकते हैं और एयर प्रीहीटर के अंदर भी यूज़ में ले सकते हैं ठीक है तो ये हमारे 5 एग्जांपल्स होता है हमारा फर्स्ट ऑफ ऑल ऑटोमोबाइल रेडिएटर दूसरा हमारा कंडेंसर तीसरा हमारा इवेपोरेटर्स चौथा एयर प्रीहीटर्स एंड फोर्थ इज कूलिंग टावर. Now we will discuss about purpose. Heat exchanger are integral part of fuel cell systems for thermal management functions related to heating of incoming gas streams, exchange of heat from various fuel streams, and maintenance of the uniformity of temperature. I repeat again, heat exchanger are integral parts of the fuel. मतलब heat exchanger मतलब कि हमारे किसी भी फ्यूल को जो इनर पार्ट जो होता है या लाइक हम कोर भी बोल सकते हैं किसी भी सिस्टम का जो है कि वो हमारा ये होता है ठीक है सिस्टम्स फॉर थर्मल मैनेजमेंट फंक्शंस रिलेटेड टू हीटिंग ऑफ इनकमिंग गैस स्ट्रीम्स एंड एक्सचेंज ऑफ हीट फ्रॉम वेरियस फ्लो स्ट्रीम्स एंड मेंटेनेंस ऑफ द यूनिफॉर्मिटी टेम्परेचर टाइप्स. Here we discuss about different types of heat exchanger like shell and tube heat exchanger. Next is plate heat exchanger. Third is plate fin heat exchanger and fourth is phase change heat exchanger. Now we will discuss about shell and tube heat exchanger. Shell and tube heat exchanger consist of a series of tubes which contain fluid that must be either heated or cooled. A second fluid runs over the tubes that are being heated or cooled so that it can be either provide the heat or absorb the heat required. A set of tubes is called the tube bundle and can be made up of several types of tubes, like plain, longitudinally, fin, etc. Shell and tube heat exchanger are typically used for high pressure applications with pressure greater than 30 bar and temperature greater than 260 degrees centigrade. This is because the shell and tube heat exchanger are robust due to their shape. Hero's thermal design feature must be considered when designing the tubes in the shell and tube heat exchanger. There can be many variations on the shell and tube design. Typically, the end of each tubes are connected planings, sometimes called water boxes, through holes in the tube sheets. The tubes may be straight or bent in the shape of the U, called U-tubes. Tube diameter. Using a small tube diameter makes the heat exchanger both economical and compact. However, it is more likely for the heat exchanger fouler, faster, and small size makes mechanical cleaning of the fooling difficult. To prevail over the fouling and cleaning problems, larger tube diameters can be used. Thus, to determine the tube diameter, the available space, cost, and fouling nature of the solids must be considered. Tube thickness. The thickness of the wall of the tubes is usually determined to ensure there is enough room for corrosion. That flow induced vibration has resistance, axial strength, availability of spare parts, hoop strength, and buckling strength. Tube thickness. The thickness of the wall of the tubes is usually determined to ensure there is enough room for corrosion. That flow induced vibration has resistance, axial strength, availability of spare parts, hook strength, and to withstand internal tube pressure. And the last but not least is buckling strength to withstand overpressure shell. Now we will discuss about tube length and tube pitch. First of all, we will discuss about tube length. Heat exchangers are usually cheaper when they have a smaller shell diameter and long tube. Thus, typically, there is an aim to make that heat exchanger as long as physically possible, release not exceeding production capabilities. However, there are many limitations of this, including space available at the installation site and the need to ensure tubes are available in lengths that are twice or equally, so that can be withdrawn and replaced. Also, long, thin tubes are difficult to take out and replace. Tube pitch. When designing the tubes, it is practical to ensure that the tube pitch, the center to center distance of adjoining tubes, is not less than 1.25 times the tube's outside diameter. A larger tube's pitch leads to a larger overall shell diameter, which leads to a more expensive heat exchanger. Tube length heat exchanger are usually cheaper. Heat exchanger are usually cheaper when they have a smaller shell diameter and a long tube length. Thus, typically there is an aim to make the heat exchanger as long as feasibly possible, limits not exceeding production capabilities. However, there are many limitations for this, including space available at the installation site, and the need to ensure tubes are available in lengths that are twice the required length. So they can be withdrawn and replaced. Also, thin tubes are difficult to take out and read. Tube pitch. When designing the tubes, it is practical to ensure that the tube pitch, the center to center distance of adjoining tubes, is not less than 1.25 times and the tubes. Outside diameters, a larger tube pitch leads to a larger overall shell diameter, which leads to a more expensive heat exchanger. This is a diagram of this shell tube heat exchanger. It is a tube, then uh, two walls are open like tube outlet and tube inlet, and shell outlet and shell inlet. And that is called baffles. Baffles, which is used to maintain the temperature of the fluid in this systems. Now we will discuss about plate heat exchanger. Another type of heat exchanger is the plate heat exchanger. This exchanger are composed to many things. Slightly separated plates that have very large surfaces area and small fluid flow passages for heat transfer. Advances in gasket increasing technology. Caution. Advances in gasket and present technology have made the plate type heat exchanger increasingly practical. In HVAC applications, which is the full form of HVAC, is heat ventilation and air conditioning. Large, large heat exchanger of these types are called plate and fan. When used in open loops, these heat exchangers are normally of the gasket type to allow periodic assembly, cleaning, and inspections. There are many types of permanently bonded plate heat exchangers, such as the deep patched, vacuum pressed, and welded plate varieties, and they are often specified for closed loop applications such as refrigeration. Plate heat exchanger also differ in the types of plates that are used and in the configurations of those plates. Some plates may be stamped with chevron, dimpled, or other pattern, where others may be have machined fins and or grooves. When compared to shell and tube exchanger, the stacked plate arrangement typically has lower volume and cost. Another differences between the two is that plate exchanger typically serve low to medium pressure fluids compared to medium and high pressure of shell and tube. So, so, a third and important difference is that plate exchanger employ more countercurrent flow rather than the cross-current flow, which allows lower approach temperature differences, high temperature changes, and increased efficiencies. Plate fin heat exchanger. This type of heat exchanger uses sandwiched passages containing fin to increase the effectiveness of the unit. The design includes crossed flow and counterflow coupled with various fin configurations. configurations such as the set fins, and wavy fins. Blade and fin exchangers are usually made for aluminum alloys, which provide high heat transfer efficiency. The material enables the systems to operate at a lower temperature differences and reduce the weight of the equipment. Plate and fin heat exchanger are mostly used for the low temperature services such as natural gas, helium, or oxygen liquefaction plants, air separation plants, and transport industries such as the motor and aircraft engines. Advantages: high heat transfer efficiency, especially in gas treatment. Large heat transfer area. Next is approximately 5 times lighter in weight than that of shell and tube exchanger. Able to able to withstand high pressure. Disadvantages might cause clogging as the pathways are very narrow. Difficult to clean the pathways, and aluminum alloys are sus- susceptible to mercury liquid embrittlement failure. Shell tube heat exchanger. Shell and tube heat exchanger consists of a series of tubes which contain fluid that must be either heated so that it can be either provide the heat or absorb the heat required. A set of tubes is called the tube model and can be made of several types of tubes. Plain, longitudinal, fin, etc. Shell tube exchangers are typically used for high pressure applications with pressure greater than 30 bar and temperature greater than 260 degrees centigrade. This is because the shell and tube heat exchanger are robust due to their shape. Several thermal design features must be considered when designing the tubes in the shell and tube heat exchanger. There can be many variations on the shell and tube design. Typically, the ends of each tubes are connected to plenums, sometimes called water boxes, through holes in the tube sheets. The tubes must be straight or bent in the shape of the U, called U-tubes. Tube diameter. Using a small tube diameter makes a heat exchanger both economical and compact. However, it is more likely for the heat exchanger to foul up faster, and a small size makes mechanical cleaning of the fouling difficult. To prevail over the fouling and cleaning problems, larger tube diameters can be used. Thus, to determine the tube diameter, the available space, cost, and fouling nature of the fluids must be considered. Tube thickness. The thickness of the wall of the tubes is usually determined to ensure first, there is enough room for corrosion. Next is that fluid-induced vibration has resistance. Third is axial strain. Fourth is availability of spare parts. Next is hook strain, which is also called to withstand internal tube pressure. And the last is buckling strain to withstand over pressure in the shell. Tube length. Heat exchanger are when they have too small shell diameter and long tube length. Thus, typically, there is an aim to make the heat exchanger as long as physically possible while it's not exceeding production capabilities. However, there are many limitations for this, including space available at the installation site and the need to ensure tubes are available in the lengths that are twice the required length, so that can be withdrawn and replaced. Also, long, thin tubes are difficult to take out and replace. Tube pitch. When designing the tubes, it is practical to ensure that the tube pitch, the center-to-center distance of adjoining tubes, is not less than 1.25 ends and the tubes outside diameter are larger tubes, which leads to a larger overall shell diameter, which leads to a more expensive heat exchanger. That's enough. And now we will discuss about phase change heat exchanger. In addition to heating up or cooling down fluid single phase, heat exchanger can be used either to heat a liquid to evaporate it or used as condensers to cool a vapor and condense to liquid. In chemical plants and refineries, reboilers used to heat incoming feed for distillation towers are often heat exchanger. Distillation sets are typically use condenser to condense distillate vapors back into liquid. Power plants that use steam driven turbines commonly use heat exchanger to boil water into steam. Heat exchanger or similar units for producing heat from water are often called boilers or steam generators. In the nuclear power plants called pressurized water reactors, especially large heat exchanger pass heat from the primary reactors plant systems to the secondary steam plant systems, producing steam from water in the processes. They are called steam generators. All fossil fuel and nuclear power plants using steam-driven turbines have surface condenser to convert the exhaust steam from the turbines into the condensate for reuse. System can also refer to heat exchanger that contain a material within their structure that has a change of phase. This is usually a solid to liquid phase due to the small volume differences between these states. This change of phase effectively acts as a buffer because it occurs at a constant temperature, but it still allows for the heat exchanger to accept additional heat. One example where this has been investigated is for use in high power aircraft electronics. Logarithmic mean logarithmic mean temperature differences. Logarithmic mean temperature differences. Here we will discuss about introductions, formula, and first of all we will discuss about introductions. The logarithmic mean, which is called LTD, is used to determine the temperature drivers for heat transfer in flow system. Most notably in heat exchanger. The LMTD means log mean temperature differences is a logarithmic average of the temperature difference between the hot and cold feeds at each end of the double pipe exchanger. For a given heat exchanger with constant area and heat transfer coefficient, the larger the LMTD, the more heat is transferred. The use of the LMTD arises straightforwardly from the analysis of a heat exchanger with constant flow rate and the fluid thermal properties. Hold on. We assume that a generic heat exchanger has two ends, which we call A and B, at the which the hot and cold streams enter or exist on either side. Then the LMTD is defined by the logarithmic mean as follows: LMTD is equal to delta TA minus delta TB, divided by a natural log of delta TA divided by delta TB is equal to delta TA minus delta TB divided by a natural log of delta TA minus natural log of delta TB, where delta TA is the temperature difference between the two streams at end A and delta TB is the temperature difference between the two streams at end B. With the definition, the LMTD can be used to find exchanged heat in a heat exchanger. Q is equal to U into A into LMTD, where Q is the exchanged heat duty in watts, U is the heat transfer coefficient in watts per Kelvin per square meter, and A is the exchange area. Note that estimating the heat transfer coefficient may be quite complicated. This holds both for concurrent flow, where the streams enter from the same end, and for countercurrent flow, where they enter from the different ends. Assumptions and limitations. It has been assumed that the rate of the change for the temperature of both fluids is proportional to the temperature differences. This assumption is valid for fluids with a constant specific heat, which is a good description of fluid changing temperature over a relatively small range. However, if the specific heat changes, the LMTD approach will no longer be accurate. A particular case for the LMTD are condensers and reboilers, where the latent heat associated to phase change in a special case of the hypothesis. For a condenser, the hot fluid inlet temperature is then equivalent to the hot fluid exit temperature. It has also been assumed that the heat exchanger coefficient U is constant and not a function of temperature. If this is not the case, the LMTD approach will again be less valued. The LMTD is a steady state concept and cannot be used in dynamic analysis. In particular, if the LMTD were to be applied on a transient in which, for a brief time, the temperature difference had different signs on the two sides of the exchanger. The argument to the logarithmic function would be the negative, which is not allowable. Plates in heat exchanger. This types of heat exchanger use sandwiched passages containing fins to increase the effectiveness of the unit. The design includes cross flow and counter flow coupled with the various fin configurations such as the straight fins, offset fins, and wavy fins. Plate and fin heat exchanger are usually made of aluminum alloys, which provide high heat transfer efficiency. The material enables the systems to operate at a lower temperature difference and reduce the weight of the equipment. Plate and fin heat exchanger are mostly used for the low temperature services such as the natural gases, helium and oxygen, liquefaction plants, air separation plants, and transport industries such as modern and aircraft engines. Advantages: higher heat transfer efficiency, especially in gas treatment. Next is larger heat transfer area. Next is approximately 5 times lighter in weight than that of shell and tube heat exchanger. And the next is able to withstand high pressure. Advantages: might cause clogging as the pathways are very narrow. The next is difficult to clean the pathways. The next is aluminum alloys are susceptible to mercury liquid embrittlement failure. Calculate overall heat transfer coefficient for valves or heat exchanger, and next is heat transfer thermal resistance. First of all, we will discuss about calculate overall heat transfer coefficient for valves or heat exchanger. Heat transfer through a surface like a wall can be calculated as Q is equal to U into A into dt, where Q is a heat transfer and its a unit is watt in joule per second, and the capital U is overall heat transfer coefficient watt per meter square into Kelvin. Capital A is equal to wall area in the meter square and feet square. And dt is equal to temperature difference like T1 minus T2, and the temperature difference overall fall, which is calculated in degree centigrade and degree Fahrenheit. The overall heat transfer coefficient for a multi-layered wall pivot heat exchanger with fluid flow on each side of the wall can be calculated as 1 divided by U into A is equal to 1 divided by HCI AI plus K summation into my Sn divided by Kn An plus K 1 divided by HCO AO. This is the equation number 2, where capital U is the overall heat transfer coefficient and the unit is meter per Kelvin. Kn is the thermal conductivity of the material in layer N and the unit is meter per Kelvin. H, C, A and O is equal to inside HCI, O is equal to inside or outside wall individual fluid convection heat transfer coefficient, and Sn is equal to thickness of the layer and meter and feet. A plane wall with equal area in all layers can be simplified to 1 divided by U is equal to 1 divided by HCI plus summation Sn upon Kn plus 1 divided by HCO. This is the equation number 3. The convection heat transfer coefficient H depends on the types of fluid, if it's gas or liquid. The next is flow properties like velocity, and the next is other flow and temperature depending properties. Uh, this slide, uh, I repeat this slide. The overall heat transfer coefficient for a multi-layer wall pipe or heat exchanger with fluid flow on each side of the wall can be calculated as 1 divided by U into A is equal to 1 divided by HCI AI with function Sn upon Kn into An plus K1 divided by HCOAO. This is the equation number 2, where capital U is the overall heat transfer coefficient and the unit is meters per Kelvin. The next is K is equal to thermal conductivity of a material layer N meter into Kelvin. HCIO is equal to inside or outside wall individual fluid convection. Inside or outside wall individual fluid convection heat transfer coefficient in the meters per Kelvin, and Sn is equal to thickness of the layer N in meter and involve with equal area in all layers can be simplified to 1 divided by U is equal to 1 divided by HCI plus the solution Sn upon Kn plus 1 divided by HCU. The convection heat transfer coefficient H depends on the types of fluid, if gas or liquid. Flow properties like velocity and other flow properties like velocity and other flow and temperature are dependent properties. Convective heat transfer coefficient for some common fluids: air 10 to 1000 watt meters per Kelvin and water 500 to 10,000 watt meters per Kelvin. Heat transfer thermal resistance. Thermal resistance is a heat property and a measurement of temperature differences by which an object or material resists a heat flow. Thermal resistance is a heat property and measurement of temperature differences by which an object or material resists a heat flow. And the next is thermal resistance is the reciprocal of the thermal conductance, where T infinity 1 or convective 1 or wall T1, T2 or convective 2 are red and T infinity 2. Transfer resistance can be expressed as R is equal to 1 by U, where R is equal to heat transfer resistance. A wall is split in sections of thermal resistance where the heat transfer between the fluids and the wall is one resistance. The wall itself is one resistance. The transfer between the wall and the second fluid is a thermal resistance, and the surface coatings or layer of burnt products adds extra thermal resistance to the wall, decreasing the overall heat transfer coefficient. Thank you. And now we will discuss about some multiple choice questions. Then the first question is, a spring is defined as an dash machine element. Option A, plastic. Option B, elastic. Option C, special purpose. या option D, none of the above. तो correct answer is option B, elastic. जब हमने जब मशीन के बारे में जब हम लोग जब डिस्कशन किया था तो उसके डेफिनेशन के अंदर हमने एक पर्टिकुलर टर्म के बारे में बात करते हैं कि अ मशीन इज द इलास्टिक एलिमेंट। और वो इलास्टिक एलिमेंट उसको क्यों कहा गया था, क्योंकि सर वो हमारी इलास्टिक की प्रॉपर्टी जो होती है उस इलास्टिक प्रॉपर्टी लाइक उस इलास्टिक की प्रॉपर्टी कैरी करती है। मीन्स कि अब जब भी कोई एक हमारी स्प्रिंग होगी, और जब उस स्प्रिंग के ऊपर जब भी एक्शन फोर्स लगाया जाता है देन वो अपनी शेप साइज से कुछ उसके ऊपर एक्सटर्नल फोर्स को रिमूव किया जाता है, वो अपनी ओरिजिनल शेप एंड साइज के अंदर वापस आ जाती है। और ये प्रॉपर्टी जो है हमारी इलास्टिक प्रॉपर्टी होती है। सो वी कॉल्ड वी आल्सो कॉल्ड कि स्प्रिंग इज द मशीनिंग स्प्रिंग इज द इलास्टिक मशीनिंग एलिमेंट which is uh, which is written in original shape and size when the remove action. So our question. Question number 2. In which of the following item a spring is used to store energy? Option A clocks, option B toys, option C circuit breakers, या option D all of the above. So the correct answer is option D all of the above. Because कि जब हम स्प्रिंग के बारे में जब हम बात करते हैं और स्प्रिंग की जब एप्लीकेशंस के बारे में जब हम लोग बात करते हैं तो उसके अंदर हम टर्म के बारे में बात करी थी, और वो पर्टिकुलर टर्म हमारी ये थी कि अ, उस पर्टिकुलर और उस स्प्रिंग एप्लीकेशंस के अंदर हमारी पर्टिकुलर टर्म ये थी कि वो हमारी किसी भी एनर्जी को स्टोर मतलब कि वो हमारे उस ऑब्जेक्ट की एनर्जी को स्टोर करके रखता है। कि मीन्स कि इस किसी भी जो पर्टिकुलर ऑब्जेक्ट को जब वो हमारी मूवेबल कंडीशन में हो और उसकी एनर्जी को अगर स्टोर करना हो तो हम उसके लिए हम स्प्रिंग को यूज में लेते हैं। और इस स्टेटमेंट को आइडेंटिफाई करने के लिए हमने सम एग्जांपल यूज में लिए थे। उनमें से ये 3 एग्जांपल भी हमारे आते हैं, लाइक क्लॉक्स हो गया, टॉयज हो गया एंड सर्किट ब्रेकर्स हो गए। कि इनके अंदर मीन्स कि जब हम लोग एक्सटर्नल फोर्स को रिमूव करते हैं, तो जब हम एक्सटर्नल फोर्स लगाते हैं तो वो जो एनर्जी सेविंग का काम जो करता है वो उसमें लगी स्प्रिंग करती है। फिर वो चाहे हमारी क्लॉक्स हो, चाहे हमारे टॉयज हो, हमारे खिलौने हो, या चाहे हमारा सर्किट ब्रेकर हो। सो कि इसका यूज जो है मतलब कि स्टोर मतलब कि इस पर्टिकुलर एप इस स्प्रिंग की पर्टिकुलर एप्लीकेशंस के लिए जहाँ पर वो हमारी स्टोर एनर्जी को स्टोर करके रखता है, उसका एग्जांपल हमारा क्लॉक्स भी हो सकता है, टॉयज भी हो सकता है एंड सर्किट ब्रेकर्स भी हो सकता है। सो द करेक्ट आंसर इज ऑप्शन डी ऑल ऑफ द अबव, लाइक क्लॉक्स, टॉयज एंड सर्किट ब्रेकर्स। क्वेश्चन नंबर थर्ड. In compression spring, the external tends to option A shorten the spring, option B lengthen the spring, option C both A and C, या ए एंड बी, या ऑप्शन डी इज कीप द लेंथ सेम। मीन्स कि इसके अंदर कहा गया है कि जब भी आप किसी भी एक पर्टिकुलर स्प्रिंग को जब आप कंप्रेस्ड करोगे, कंप्रेस्ड का मीन्स कि उसको दबाओगे, तो एक्सटर्नल फोर्स कहाँ मतलब कि कहाँ टेंड करेगा, मीन्स कि उस स्प्रिंग की जो है कि हमारी उस स्प्रिंग की शेप एंड साइज या उसकी प्रॉपर्टी क्या हो जाएगी। देन कि हम जानते हैं कि सर किसी भी स्प्रिंग या किसी भी ऑब्जेक्ट को जब आप लोग कंप्रेस करोगे, दबाएंगे, देन जो उस स्प्रिंग की जो लेंथ जो है या शेप एंड साइज जो है वो हमारी स्मॉल हो जाएगी, शॉर्ट हो जाएगी। सो द करेक्ट आंसर इज ऑप्शन ए, शॉर्टन द लेंथ। क्वेश्चन नंबर फोर्थ. Torsional shear stress are induced in the spring wire when option A spring is under compression, option B spring the under tension, option C both A and B, या option D none of the above। मीन्स कि कहा गया है कि जब किसी भी स्प्रिंग वायर में टॉर्जनल शेयर स्ट्रेस लगाया जाए तो इसके अंदर से कौन सी कंडीशन होगी कि स्प्रिंग हमारे कंप्रेशन के अंदर वर्क करेगी, वो हमारे टेंशन के अंदर वर्क करेगी, वो हमारी दोनों के अंदर वर्क करेगी, या दोनों के अंदर ही वर्क नहीं करेगी। सो द करेक्ट आंसर इज ऑप्शन सी बोथ ए एंड बी। बिकॉज कि जब भी हम शेयर स्ट्रेस के बारे में बात करते हैं तो शेयर स्ट्रेस के अंदर हम शेयर स्ट्रेस के साथ साथ उसके कॉम्प्रेशन प्रॉपर्टी एंड एक्सटेंशन प्रॉपर्टी ऑब्लिक टेंशन प्रॉपर्टी के बारे में भी अपन बात करते हैं। सो द करेक्ट आंसर इज ऑप्शन सी, बोथ ए एंड बी, लाइक स्प्रिंग आर वर्किंग अंडर द compressions एंड टेंशन। क्वेश्चन नंबर फिफ्थ। Question number fifth. The helix angle in case of the closely coiled helical spring. Option A less than 10 degree. Option B 10 degree to 15 degree. Option C 15 degree to 20 degree. या option D more than 20 degree. So the correct answer is option A less than 20 degree. Means कोई भी स्प्रिंग जो कि हमारी क्लोजली कॉइल हेलिकल स्प्रिंग होगी, तब उसके अंदर जो हेलिक्स एंगल होगा उस वो कितने डिग्री पर मूव करेगा या कितने डिग्री पर वो एक्सटेंड करेगा, कितनी डिग्री पर स्टैंड करेगा। सो द करेक्ट आंसर इज ऑप्शन ए लेस देन 10 डिग्री। मीन्स कि उसका जो एक जो एंगल जो होगा वो हमारे 10 डिग्री से भी कम होगा व्हेन द स्प्रिंग आर वर्किंग एज अ क्लोजली कॉइल हेलिकल स्प्रिंग। द हेलिक्स एंगल इन केस ऑफ क्लोजली कॉइल हेलिकल स्प्रिंग। ऑप्शन है लेस देन 5 डिग्री, ऑप्शन बी 5 डिग्री टू 7 डिग्री, ऑप्शन सी 7 डिग्री टू 10 डिग्री, या ऑप्शन डी इज मोर देन 10 डिग्री। सो द करेक्ट आंसर इज ऑप्शन सी मोर देन 10 डिग्री। मीन्स कोई भी जो एक हमारी क्लोजली कॉइल हेलिकल स्प्रिंग जो हमारी होगी, वो उसका मतलब कि उस हेलिकल स्प्रिंग हमारी क्लोजली कॉइल्ड हेलिकल के अंदर उसका जो एंगल जो होगा वो हमारे 10 डिग्री से ज़्यादा होगा। सो द करेक्ट आंसर इज ऑप्शन डी मोर देन 10 डिग्री। क्वेश्चन नंबर 8। The longest leaf in semi-elliptical leaf spring is known as option A chief leaf, option B master leaf, option A chief leaf, option B master leaf, option C major leaf, या option D higher leaf. So the correct answer is option B master leaf because it is the semi-elliptical leaf in the case of the longest leaf. Question number 7. Helical torsion spring is used in option A door hinges, option B door closures, option B automobile starters, या option D all of the above. So the correct answer is option D all of the above because कि हेलिकल टॉर्जन स्प्रिंग का यूज जो है हम लोग टॉर्जन स्प्रिंग डोर हिंग्स में भी कर सकते हैं, डोर क्लोजर्स में भी इसका यूज किया जाता है, और ऑटोमोबाइल स्टार्टर्स के अंदर भी हेलिकल टॉर्जन स्प्रिंग का यूज किया जाता है। सो द करेक्ट आंसर इज ऑप्शन डी ऑल ऑफ द अबव। Question number 9. The leaf of multi-leaf spring are subjected to option A bending stress, option B shear stress, option C axial stress, या option D is all of the above. So the correct answer is option A bending stress because कि जो एक हमारी मल्टी लीफ स्प्रिंग की जो लीव्स जो होती है वो हमारी बेंडिंग स्ट्रेस के साथ में प्रभावित होती है, बेंडिंग स्ट्रेस के साथ में सब्जेक्टेड होती है, ये बेंडिंग स्ट्रेस के साथ में डायरेक्टली प्रोपोर्शनल होती है। व्हेन we increase the multi-leaf spring, then bending stress also increase, and then when decrease the multi-leaf spring, bending stress is also decrease. So the correct answer is option A, bending stress. Question number 10. Question number 10. Multi-leaf spring are used in automobile suspension. Option B, railroad, railroad suspension. option C both A and B, या option D none of the above. So the correct answer is option C both A and B, because मल्टी लीफ स्प्रिंग का यूज जो है हम लोग ऑटोमोबाइल सस्पेंशन में भी कर सकते हैं एंड रेल रोड सस्पेंशन में भी इसका यूज किया जा सकता है. सो द करेक्ट आंसर इज ऑप्शन सी बोथ ए एंड बी. ऑटोमोबाइल सस्पेंशन एंड रेल रोड सस्पेंशन आर यूज्ड इन द मल्टी लीफ स्प्रिंग. Question number 11. The spring index C is option A mean coil diameter oblique wire diameter, option C wire diameter oblique mean coil diameter, option C wire diameter into mean coil diameter, या option D none of the above. So the correct answer is option A mean coil diameter divided by wire diameter, because कि इस spring index का use जो है हम लोग मतलब कि स्प्रिंग इंडेक्स का फॉर्मूला हमारा होता है मीन कि हम जानते हैं कि सर स्प्रिंग इंडेक्स हमारी मीन किसी भी स्प्रिंग के मीन कॉइल डायमीटर और वायर डायमीटर का रेशियो होता है. देन द स्प्रिंग इंडेक्स विच इज डिनोटेड बाय सी, द फॉर्मूला इज मीन कॉइल डायमीटर कैपिटल डी अपॉन वायर डायमीटर स्मॉल डी. सो द करेक्ट आंसर इज ऑप्शन ए मीन कॉइल डायमीटर डिवाइडेड बाय वायर डायमीटर. Question number 11. Question number 12. The spring index indicates the relative sharpness of the dash of the coil. Option A length, option B curvature, option C thickness, या option D none of the above. So the correct answer is option B curvature. कि जो हमारी स्प्रिंग यहाँ पर हमसे पूछा गया है कि जो स्प्रिंग इंडेक्स हमारी कॉइल की मतलब कि शार्प मतलब कि कॉइल की किस शार्पनेस को डिफाइन करती है, तो इसका सही आंसर होगा कर्वेचर. मीन्स कि कोई भी एक स्प्रिंग को कितना अमाउंट ऑफ कर्व देना, या उसके कर्व का एंगल कितना होगा, या उसकी क्या वैल्यू होगी, इस चीज को जो है हम लोग स्प्रिंग इंडेक्स विच इज डिनोटेड बाय सी के थ्रू डिफाइन कर सकते हैं. सो द करेक्ट आंसर इज ऑप्शन बी curvature, which is used for the indicates and represent the sharpness of the curvature of the coil. Question number 13. A spring index from is considered as best for the manufacturer considerations. Option A 4 to 12, option B 12 to 20, option C 20 to 28, या option D is 28 to 36. So the correct answer is option A 4 to 12. मीन्स कि किसी भी एक मैन्युफैक्चरिंग कंसिडरेशन के लिए अगर हम लोग ये सोचें कि स्प्रिंग इंडेक्स की वैल्यू कितनी होनी चाहिए, तो हम लोगों को पता है कि किसी भी मैन्युफैक्चरिंग कंसिडरेशन के लिए जहाँ पर हम स्प्रिंग की डिजाइनिंग करें, वहाँ पर हमारे स्प्रिंग इंडेक्स की वैल्यू 4 to 12 होनी चाहिए, मीन्स 4 से 12 होनी चाहिए. सो द करेक्ट आंसर इज ऑप्शन ए 4 to 12. Question number 14. Axial length of the spring which is so compressed that the adjacent coil touch each other. Option A compressed length, option B solid length, option C free length, या option D none of the above. So the correct answer is option B solid length. कि axial length of the मतलब कि किसी भी एक spring जो उसको कंप्रेस करती है जहाँ, और वहां पर जो हमारी जो एडजस्टेंट कॉइल जो होती है, जो कि मतलब कि एक कॉइल दूसरे को और दूसरे कॉइल के साथ टच होती है, मींस कि इस की कॉइल 1 कॉइल 2 के साथ टच होगी, कॉइल 3 के साथ में टच होगी, और कॉइल 3 4 के साथ में टच. तो ये जो एक दूसरे के साथ में जो होते हैं कनेक्ट होते हैं, तो ये कौन सी को कंसीडर कर यहाँ पर हम बताएंगे कि ये हमारे विच टाइप्स ऑफ लेंथ आर इन दिस ट्रीटमेंट. देन correct answer is option B. So, question number 15. Axial length of an unloaded helical compression spring is called option A compressed length, option B solid length, option C free length, या option D none of the above. So the correct answer is option C free length. कि अगर मतलब कि कोई भी एक हमारी स्प्रिंग है जो कि हमारी एक्सियल लेंथ कंसिडर कर रही है और उसके ऊपर किसी भी तरह का कोई लोड नहीं लग रहा, वो हमारी अनलोडेड है और उसको अगर हम लोग अनलोडेड हेलिकल कंप्रेशन स्प्रिंग बोल रहे हैं, देन which types of length are used in this statement? So the correct answer is option C, free length. कि अगर किसी भी स्प्रिंग के ऊपर कोई भी लोड हमारा नहीं लग रहा है, मीन्स कोई एडजस्टेंट कोई एक दूसरे के साथ में टच में नहीं आ रही है, एक दूसरे के साथ में कनेक्ट नहीं हो रही है, देन वो मतलब देन उस कंडीशन के अंदर जो हमारी लेंथ कंसिडर की जाएगी वो हमारी फ्री लेंथ होगी. सो द करेक्ट आंसर इज ऑप्शन सी, फ्री लेंथ. The force question. The force required to produce unit deflection is known as the option A gradient of spring, option B stiffness of spring, option C spring constant, या option D all of the above. So the correct answer is option D, all of the above. कि मीन्स कि जो एक हमारी किसी भी स्प्रिंग के अंदर जो एक फोर्स रिक्वायर्ड है डिफ्लेक्शन को प्रोड्यूस करने के लिए, उसको हम क्या बोलेंगे सर? उसको हम ग्रेडियंट ऑफ स्प्रिंग भी बोल सकते हैं, स्टिफनेस ऑफ स्प्रिंग भी बोल सकते हैं एंड स्प्रिंग कांस्टेंट भी बोल सकते हैं. सो द करेक्ट आंसर इज ऑप्शन डी, ऑल ऑफ द अबव, बिकॉज इन दिस स्टेटमेंट which also known as gradient of spring, stiffness of the spring and spring constant. Next. The coils of the spring which are in contact with the seat and do not contribute to spring action are called option A resting coils, option B static coils, option C inactive coils, या option D ideal coils. So the correct answer is option C inactive coils. मीन्स कि जो एक हमारे coils of the spring जो होगी जब वो हमारी सीट के साथ में कनेक्ट को कंट्रीब्यूट नहीं कर रही है, types of coils are used in the coils. Question number eight. Following is are styles as of and style of having compression spring. Option A plain ends, option B pen and ends, option C square and option D all of the above. So the correct answer is option D all of the above. हम लोग उसके अंदर प्लेन एंड का जो एंड का जो कॉन्सेप्ट है एंड ऑप्शन जो हम इसका जो कॉन्सेप्ट है उसको भी यूज में लिया जाए. So the correct answer is option D, all of the above, means plain ends, plain and ground ends, which are used in the form of the helical compression spring for a end style end. Number of inactive coils in plain end is R. Option A 0, option B 1, option C 2 या option D 3. कि मतलब किसी भी प्लेन एंड के अंदर इनएक्टिव मतलब कितने नंबर ऑफ इनएक्टिव कॉइल्स होंगे तो वो हमारे जीरो होंगे. मींस कि जब भी हम प्लेन एंड के बारे में बात करते हैं तो उसके अंदर हमारी जितनी कॉइल्स होती है वो सारी एक्टिव होती है. मींस उसके ऊपर एक्सटर्नल फोर्स को कंसिडर किया जाता है, उसकी शेप एंड साइज इस तरीके की होती है. सो वहां पर इनएक्टिव कॉइल्स हमारी नेग्लिजिबल हो जाती है. सो द करेक्ट आंसर इज जीरो फॉर द यूज ऑफ द इनएक्टिव नंबर ऑफ इनएक्टिव कॉइल्स इन द प्लेन एंड. Question number next. The length of one coil in the spring is option A pi into d, option B 2 pi into d, option C pi d by 2 या option D pi d by 4. So the correct answer is option A pi into d, which are used for the वन कॉइल इन की किसी भी स्प्रिंग में वन कॉइल के लेंथ को मेजर करने के लिए जो एक पर्टिकुलर फॉर्मूला यूज में लिया जाता है वो लिया जाता है पाई इंटू डी. क्वेश्चन नंबर नेक्स्ट. द स्ट्रेन एनर्जी विच इज डिनोट The strain energy, which is denoted by E, where P is equal to load and delta is equal to deflection of the spring. Well, the formula is P delta by 2 to P delta. Option C, P delta by 3. The option D is P delta by 4. So the correct answer is option A, P delta by 2, which is used in the strain energy load. For two spring in series, effective spring K is where K1 and K2 are stiffness of the spring 1 and 2 respectively. Option A, K1 K2 by K1 K2 divided by K1 plus K2. Option B, K1 plus K2. Option C, K1 K2. Yeah, option D is K1 plus K2 divided by K1 K2. So the correct answer is option A, K1 K2 divided by K1 plus K2. Next, for two spring in parallel, effective stiffness, which is denoted by K, is where K1 and K2 are stiffness of the spring, first and second respectively. Option A, K1 K2 divided by K1 plus K2. Option B, K1 plus K2. Option C, K1 K2. Yeah, option D is K1 plus K2 divided by K1 K2. So the correct answer is option B, K1 plus K2. A factor of safety in the design of a spring is usually option A 1.5 or less, option B 3 or less, option C 4.5 or less, yeah, or option D 6 or less. So the correct answer is option A 1.5 or less. A concentric spring consists of two helical compression spring is option A. Both spring always have right hand helix. Option B. Both spring always have left hand helix. Option C. Both spring always have opposite end of helix. Yeah, option D is any of the above. So the correct answer is option C. Both spring always have opposite hand of the helix. Next question. Concentric spring are used in option A, heavy duty diesel engines, option B, aircraft engine, option C, railroad suspension, या option D, none of the above. So the correct answer is option D, none of the above, because concentric spring जो है वो हमारी heavy duty diesel engine के अंदर भी यूज में आती है, aircraft engine के अंदर भी इसको यूज किया जाता है और railroad suspension के अंदर भी इसका यूज किया जाता है. The initial gap between the extra full length leaf and the graduated length leaf before the assembly is called option A clearance, option B nip, option C gap, or option D I. So the correct answer is option B nip. The method used to induce a layer of the residual compressive stress on the surface of the spring wire is option A short pinning, option B burnishing, option C lapping, option D none of the above. So the correct answer is option A short pinning. Thank you.